Moving on to the third page, question 13. We read through this. Well, we're going to start off with our combined gas law equation. So we have a 2-liter rubber balloon with filled with carbon dioxide in warm environment. So we have 25 degrees Celsius and a pressure of 745 millimeters of mercury. And it says, what will the volume of the gas be if it's taken out of the open air where the temperature is now negative 12 degrees Celsius and our new pressure is 742. Because it gave us two pressures and they're asking for a second volume, we're going to use the combined gas law equation. So our first pressure was 745 right here, and our first volume was 2 liters. Now our first temperature is 25 degrees Celsius, but again, remember we're going to convert that to Kelvin by adding 273. So we get 298 Kelvin equals our new pressure is going to be 742. We're solving for volume 2, and our new temperature is now 273 minus 12, which would be 261. So what we're going to do here, normally we would cross multiply and divide, but we just have to multiply once, twice, and then we're going to divide once and then twice. So if you watch from the calculator here, so we're going to have 745 times 2 liters. And then we're going to multiply that by 261. So there's my 2 multiplies. Now I'm going to divide twice. Divide by 298. That's my first division. And I'm going to divide a second time. Divided by 742. My final answer would be 1.76 liters. Question 14, a given mass of gas occupies a volume of 640 at 47 degrees Celsius and 645. So they gave us pressure, volume, and temperature. So we're probably going to be using the combined gas law equation. Now we read through what is the new temperature. So we're solving for T2 if the volume is decreased, but the pressure remains unchanged. So if pressure is unchanged, we can cross out our equation, and there's what we're solving for. V over T equals V over T. So our first volume, we will go back here at 640, and our first temperature is 47 degrees Celsius. So we convert that to Kelvin by adding 273. Our new volume is 250. Now we're just solving for our new temperature. So we're going to cross multiply and then divide. So 250 times 320 divided by 640 gives us a new temperature of 1250 K. Oops, sorry, excuse me. Got to hit one more zero there. 125, excuse me. Question 14. So right here, we read through a quantity of acetylene is in a steel cylinder under pressure of 1.2 atm at 27 degrees Celsius. What will the new pressure be if the temperature is increased? Now they did not give us a volume at all, so it's just going to be P over T equals P over T. So first pressure here is going to be 1.2 divided by our degrees in Kelvin. So we add 273 to our degrees Celsius. And our new pressure is, well, we don't know. That's what we're trying to solve for. And our temperature is increased to 97 degrees Celsius. So we add that to our Kelvin. And we get 1.2 multiplied by 370 divided by 300. So we get 1.2 times 370 divided by 300 would give our new pressure of 1.48 atm. Okay. Next question, 16. It says 400 milliliters of gas at minus 23 degrees Celsius at 750 pressure will occupy what volume at standard temperature and pressure? That's what STP is, standard temperature and pressure. Quick review, standard temperature is 273, and then pressure is going to be 101.3 kPa, 1 atm, or 760 mmHg. So we look here, we're asking for the new volume. So our first pressure is going to be 750, and our first volume is going to be 400. And then our temperature is minus 27 degrees, 23, so we add that to 273 and we get 250 K equals our new pressure. Well, our new pressure has to be one of our standard temperature and pressures. Since we're using millimeters of mercury, we're going to use 760. Volume 2, we don't know what it is yet, and our standard temperature is 273. So just like we did on question 14, we're going to multiply twice and divide twice. Let's get you here so you can see the calculator. So we're going to go 750 times 400. Notice I hit n equals. Now I'm going to multiply again by 273. Now I'm going to divide by 250. He equals, and then divide one more time by 760. And my second volume is going to be 431 milliliters. All right, next question 17. Calculate the total pressure of a mixture. So total pressure is simply all of the pressures added up. So it's pretty straightforward here. We have 420 plus 180 plus 200. We just simply add those together and we get 800 millimeters mercury for our total pressure. Last question on this page is talking about collecting gas over a water sample. So that equation is pressure of the gas is going to equal the total pressure minus the pressure of water. So we have a 25 degrees Celsius, which means the pressure of water is going to be 23.8 mmHg. And our total pressure was 747.8. So we put that into our equation. We get our pressure of the gas is 724 millimeters of mercury. And that's page 3.